So yeah, apparently the schedule didn't say what I was talking about, so thanks for coming literally just for my name. That's kind of weird, but I appreciate it. This talk that I gave this at a DevOps Days Austin, very similar talk. It's a little bit updated, but James Wickett, who's the organizer here, thought that it would be good to kind of give a more developer defense type focused talk at a security conference. Usually, if you guys have been to LASCON before, I've spoken here the past couple of years, and usually it's very like, here's how I'm going to break everything and then just walk out and not tell you how to solve it. This is kind of a little bit different, how I broke everything and how to solve it. Just by a show of hands, so I know my audience, who here has heard of Kubernetes? Okay, who here has used Kubernetes? Always a smaller number. Cool. That's really interesting. Okay, so I'm going to give just a quick overview of Kubernetes for a bit. Maybe talk a little bit about some containerization. Then we'll talk about some security pitfalls and some benefits, and how to avoid some of them. All right. First of all, thank you for letting me leave work to give a talk to my company, Honest Dollar. We're down here in Austin. We're hiring developers specifically. If you guys are looking for a job, we're right downtown. We're a fintech company that does like retirement savings plans alternatives. Okay, I promise I won't say any more. Well, you all came just for my name, so hopefully you at least recognize it, but which is just still super strange to me. But yeah, I've done this security thing once or twice. I head up security for Honest Dollar, and yeah, we'll go from there. So, okay, so what is Kubernetes? That's what we're going to kind of talk about a little bit. I have no idea if I'm pronouncing it right, so please don't ask me. We can just go with Kube or Kates or something like that, but I say Kubernetes. I really I always like asking that question early on and see how many hands go down who's actually used it. It's really interesting to me, first of all. Second of all, the why to use it is always really interesting. Like, okay, well, why are you using Kubernetes? And hopefully the answer is not because like Netflix does it or something like that. Like, hopefully there's like some benefit in your mind to doing like a microservice architecture. So we'll talk a little bit about that. Security pitfalls. Basically, we're gonna hit on some things where if you follow the documentation to the letter on Kubernetes, you wind up with a pretty insecure architecture, at least up to my standards. And so this was something that I kind of had to deal with walking into an organization using this and having never really played with it before. But there is a lot of benefits also. So just right out of the box, there's a whole bunch of stuff, and we'll talk about that. And I promise no live demos. I didn't sacrifice the requisite goat, so that would probably fail anyway. So we'll just talk about some examples without any demos. So for those of you who didn't raise your hand early on about you don't know what Kubernetes is, really quickly, it is basically just to sum it up, it's a containerization orchestration tool, right? So if you want to use Docker containers, that's great. Docker containers are fun. But if you want to use them in kind of an enterprise microservice architecture, full stack type of deal, having something to orchestrate all of them, where they spin up, when they spin up, how many of them spin up, the whole life cycle of a container, Kubernetes is kind of the leading tool for that right now. There was some competitors that have kind of fizzled. This is kind of the one that's sticking around. The other key thing to know about it is just also curious, how many people have used Google Cloud, like instead of AWS, like Google Cloud Services? Not that many of you, okay. So they've got like an AWS competitor type thing, and one of the options is just Kubernetes right out of the box. So if you're using, it's called Google Container Engine, and if you're using that, you're using Kubernetes whether you knew it or not. You probably knew it if you were using it. Okay, so what does it look like, right? So Kubernetes, there's this concept of a master node. I'm not going to go too deep into this, but there's this concept of a master that's going to give instructions to a bunch of different nodes. You're going to hear me say a bunch of words. I promise I'll explain what they all mean soon. But basically, this is just, there's this overlay network that you kind of have to know about. And then this master is going to be able to distribute containers across all of these nodes, tell them what to do, tell them everything. This slide is more here for reference. I'm not going to go too deep into this. But it's just pulling Docker images and sorting them out and doing all sorts of cool stuff. So one of the hardest things for me me in terms of the learning curve coming up to speed with Kubernetes when I first started at this job and had no idea because I was just, some security guy who didn't know enough about the new cool hot tech, was the words being used, right? I was sitting with my developers and they said, oh, well, we're going to do this with this pod and this replication controller. And I just said, you got to slow down. I don't even know what words you're saying, right? So just a quick definition of some things you're going to hear me say, and feel free to shout at me if I start saying stuff that you don't know what means later on, because I'm starting to take it for granted. So when I say node, you hear VM in Kubernetes land. It's like that's the VM that a bunch of containers are on. A pod is just a group of containers, right? So it's like, okay, you're in a microservice architecture, you might have a group of containers that do one singular task, right? So you have an authentication service that's going to be some container that does token handling, some that does logging, some that does something else. And okay, these three containers are the authentication service. They make up a pod. Replication controllers, these are, and services, these are the set of YAML files. And that's why I say YAML land. You kind of have to get used to a bunch of YAML files if you're going to play with Kubernetes. Replication controllers and services are basically the configuration files of how to spin all of them up and down and everything you want to do with them. And a cluster is a network. You're going to think of it like its own Kubernetes cluster is its own network. It's its own group of nodes, right? So, like I said, the YAML stuff is super important. If you're gonna start playing with Kubernetes, you're gonna have to learn. Okay, how do I set up these replication controller YAMLs? And I'll bring up some examples of that later. Some different environments, some persistence. These things all kind of should be obvious to you guys. And but I like this one quote, right? So the secret sauce. This quote's from one of my infrastructure architects, and he goes, "Docker is not actually the secret sauce. That's not the magic. We don't really care what containerization tools we're using. A lot of people say Docker this, Docker that, and it is 99% of the containerization market. But you can sub in whatever containerization technology you want, and really the orchestration is what allows you to do some reap the benefits of using this technology anyway, right? So learning this stuff is super important. Let's talk about pitfalls. So like I said, if you follow the documentation, you're gonna and which most people would, right? Obviously, that's why it's there. You're gonna find yourself into some issues. So one of them is they've got this concept of namespaces that they try to get you to set up, which says, okay, namespace is dev or QA or prod or whatever it is, and it all sits on one cluster. So as a security guy, when I came in and look at this infrastructure, I say, do you mean that all of that stuff is on the same network and they can all talk to each other? So our production data is on the same network as our dev environment and as our QA test code that hasn't been reviewed and so on and so forth? And the answer is basically yes, right? So if you go down this namespace road, this is kind of the first pitfall that you run into. And this is how they teach you to set it up, right? So this is what it looks like, right? I've mentioned the YAML files a few times. So this is a service or a replication controller, one of them. And it is basically the definition of all your different namespaces, right? So it says, okay, cool. I got dev, I got QA, I got prod, and just spin them all up in the same area, please. The other thing you end up with if you go down this path is a lot of duplication of work. Because if you're going to do all of this in one cluster, you're going to have all of these different YAML files that look almost identical, and the version control gets really nasty, and it's really error prone, right? Again, following the documentation, this is what you end up with. And it gets really hairy really quickly, and it's super error prone, and you end up with a network of everything that lives on them. That's why I said the cluster, that one cluster to rule them all kind of thing, right? So this is just not the way to go. A really easy fix on this. I have an update here also, but a really easy fix on this is to just do separate clusters, right? Kubernetes just lets you make separate clusters, so why wouldn't we do that? This effectively makes them completely different network spaces, different IP spaces. They don't even know about each other unless you specifically tell them that they can talk to each other. In the most recent version of Kubernetes 1.4, I think, there's a concept of subnets, which is another alternative to this. You can still segregate the networks, but that's a very new feature. So I don't know too much about it, but it's kind of effectively solves the same problem in somewhat of a cleaner way instead of having to create VPNs in between all these networks, right? Back to the duplication of work, if you have all of those YAML files that are all just going to be saying the same thing over and over and over again, that gets really messy. So one of the ways that you can solve this, Puppet has an answer to Kubernetes, kind of. It's getting there. It's in beta, I think. It's not quite there yet. But you can just kind of go back to the some old faithful tools and just start parameterizing all of this stuff. And for a security guy, that makes me really happy because now I know you're going to make one change in one place. I know exactly what you changed. I know where it ended up, and I know what environment it's running in, right? So this little screenshot from one of my developers when I asked him for some content for this, he had to comment out "drink beer" for some reason. But yeah, so basically just in one command, and as little commands possible, set up your entire environment. Also, very recently, as in past couple of months, there's now a tool called Helm. If you're really interested in this, you should write that down. Helm will stand up will do a lot of this stuff for you in a Puppet and Chef-esque way, but a little bit more container friendly, right? So again, this is going to allow you to track all of your versions. You know what code's running where. This is going to allow you to really reduce errors. And again, it's just not following the documentation. You kind of have to realize that what you're doing is you got to think about it a little bit more, right? The dependencies are another big one, right? If you're going to be duplicating all these dependencies everywhere, I'm guessing everyone in the room has kind of played with Docker. At least most of you have played with Docker, right? One of the things that people just kind of gloss over in Docker files is the base image, and then you start worrying about, okay, why are we using Ubuntu for this thing that does this one little thing? So there's a lot of stuff. A lot of people are using Alpine now. I don't know if you guys have heard of that. It's like a purposely small Linux, and you start worrying about dependencies a lot less, right? All right. This was my bane of my existence for a long time here, right? So again, following the docs, this is what you end up with if you're going to use Nginx as a reverse proxy or web server in your Kubernetes cluster. You can make it a type load balancer, which means, okay, it'll spin up. It does some really neat stuff, right? It'll spin up a bunch of Nginx containers for you and do all sorts of really neat load balancing things right out of the box. But what this actually does is it changes it from HTTP traffic to network traffic as soon as it hits the cluster, which means you lose all source information. You have no idea where this request came from an HTTP like weblog format. You're going to look at your logs and it's all going to be 10 internal IP addresses. Right? And so I came on board. I was like, hey, why is all of our, what's going on? Every web request we've ever got is internal. What's going on? And this is the reason. Again, straight out of the documentation. I think I took this picture from the docs. I don't think I took this picture from something I typed up. So the header information is gone, is what I'm saying. It turns from HTTP to network traffic, and you lose HTTP headers information in your logs. I went on to the Kubernetes GitHub. It's an open source project. Went on to the GitHub, opened an issue, and one of the Kubernetes guys said, well, that's how cloud networking works. So unless you change cloud networking, you can't change this. So there's a bunch of security guys on that comment chain saying, what? Like, how is that the answer kind of thing? But okay, right? So they did introduce a concept of an ingress controller, and you can kind of set this ingress controller up as the way to get into your Kubernetes cluster. I spent an embarrassingly long time trying to get that to work. If someone knows how to get that to work, let's chat afterwards. But basically, that along with some other things, the solution really here for us was pull Nginx out of Kubernetes. Just put Nginx on a raw VM, and then that's the gateway for HTTP traffic, and then you get all you still preserve all your information, and you can kind of pass it along. There's definitely other solutions. That was just one of the easy ones, and then it also makes all sorts of other plugin stuff available. So just because you can containerize it and use it in Kubernetes doesn't mean you should all the time necessarily. A lot of technologies haven't really caught up to the fact that people are sticking it in containers and using it that way. A lot of integrations all of a sudden go away. This one was really tricky, but we pulled it out. This is my other funny one. So when again I got hired and I came in and I started looking at the environment and I said, okay, I'm going to do what any security person would do and sit down and kind of wall off the environments and like try to control traffic in and out. And so I know limit sources and all sorts of stuff. Try to limit kind of attack surface, right? Basically is what I'm getting at. So I created this whole bastion jump host situation for SSH, all SSH traffic. If you wanted to get into the Kubernetes cluster, had to go through this one box. Spent like, too much time on it. And I went over to my developers. I said, hey guys, I'm going to roll this out into dev. This is how you're going to have to get into the environment now. And like, it's just one extra hop for you and so on and so forth. And they said, that's cool, but we don't really use SSH. We use this kubectl thing. How many of you guys have played with kubectl? You guys, okay. So it's kind of like the Swiss Army knife command line tool for interacting with your Kubernetes cluster. It's something that I would never really take away from my developers. They wouldn't really be able to do much anywhere near as quickly. It's super, super handy. But as you can see from the screenshot, hopefully while I've been talking, there's an issue, right, with this. And that command absolutely works. Who wants to shout out what that command does? On any container that you want. Just hop into any container that you want. So I set up this whole nice walled garden situation and my developers laughed at me and ran that command and then did whatever they wanted, right? Probably comment out, drink beer, right? But anyway, so they looked at this and I got kind of nervous because I didn't really know how to lock this down. But I looked under the hood. What it's doing is creating an HTTPS proxy, so it's not using SSH, which is a port that I can't close. I hope the AppSec crowd understands that one. And yeah, it's just this HTTPS reverse proxy to the Kubernetes master. Then the Kubernetes master gives you SSH connections to the nodes, and just you hop right on the box. This one's tricky to lock down. You can get kind of creative and start working with proxies to try to get a handle on this, but they're not, like, enough security people, including myself, have looked under the hood here and they're not doing anything insane. So it is actually a relatively secure connection. They are using your Google credentials to hop in, well, at least in GKE. Yeah, you kind of have to get creative and watch out for this. So I like to shout it out because my developer is just laughing at me, and all the work I put in for the jump host situation was not a good feeling on my first week on the job. It's like, okay, great, thanks guys. All right, so let's talk about benefits really quick, right? So that's enough pitfalls that you'd run into if you just follow the documentation and if you are a security person that's faced with a company deciding if they're going to use this. Those are some pitfalls. So let's talk about some benefits. There's some security benefits of containerization in general. There's probably dozens of talks about that already, so I'm not going to spend too much time on it. But really quickly, I really like when it comes to patching, or if you find some sort of vulnerability in some service running inside of a container, worrying about patch management is as simple as, oh, we'll just rebuild that container. It's going to grab the latest stuff most of the time, or you can tweak a fix really quick and then just deploy it. Basically, a lot of these benefits are going to boil down to how easy it is to deploy these things and how it's kind of natural for them to have a really short life cycle, right? If you're doing microservices correctly and using containerization correctly, there should only be one process per container. Some people like to use containers like their VMs. Like, hey, look at my, 2-page long Docker file that installs all of this stuff on this machine as I go. It's like, well, why did you use a container? You wanted like one file, I guess. I don't know. That's not really what they're for, right? Using like that removes a lot of the benefits that you're going to get from containerization in the long term. So if you keep it to the one process per container, that again limits surface area, and exactly if you're having some sort of security event, exactly which part of your infrastructure is the culprit, right? And you could do a lot of things. Touching on it being host agnostic, it doesn't really care what VM it's running on, right? As long as it knows how to run on that VM, it doesn't care which one it's on. So if you have a problem with not the container, if you have a problem with the underlying host, you can just shut that host off and Kubernetes will find another place to put your container, right? So operating system level concerns, security concerns get kind of much easier to fix, actually, right? Because you can just kind of pull those things out of service and not really affect your website traffic at all. Segregation, it gets pretty easy when you break your application up in such a granular level. It gets pretty easy to control what can talk to what, right? So if you have your production level data, like I was saying earlier, right? If you have your production level data and you want to make sure that only one piece of the code can access customer data, then you can like monitor and surveil that all day long, or put specific monitoring. And for those of you coming around tomorrow, there's a talk about Audit D by Ryan Huber. You should definitely go see that. And I used the tool that he's going to be talking about a lot to beef up some of the monitoring in very sensitive parts of the application, which is, it gets really easy once you start segregating into these microservices. The other thing is the lifespan of these things tend to be hours to days, right? If you're in a agile dev environment and you're using microservices, if you're using microservices, you're almost certainly an agile dev environment, right? I doubt there's very many Kubernetes customers that are doing, waterfall type stuff. But the containers, like you can look at that kubectl tool can pull up the age of all of them, and almost all of mine are sub a day, maybe a few days kind of thing. Whereas, like, there's been a few tweets that go around that are people bragging about how long they've kept some Linux server going, and I'm like, man, I feel bad for that system administrator trying to keep this thing alive for months, years, that kind of thing. So again, though, if from a security benefit point of view, these things go away, come back alive, do whatever they want whenever you want, and so that limits a lot of issues. Kubernetes in general, so that's containerization. Kubernetes in general, the upgrade process is really, really, really easy. That's kind of what it's built around, is this whole flowing containers from one node to another. So as you upgrade, you can kind of just move things off of boxes, bring up upgraded boxes, moving around. I mean, this is a concept that's been around for a long time, but Kubernetes has it pretty much out of the box. The logging is great. The build pipeline stuff, continuous integration. So that's what I talked about here last year was security and continuous integration. And just to harp on it a little bit more, I don't think it's a nice to have anymore. People are like, oh, okay, do you do, how many times a day do you push code to production or all that kind of stuff? And that's like the new hot metric, and everyone thought it was like this nice to have thing. And yeah, it still kind of is. And yeah, if you're trying to make money and be a high-tech company and get developers, there's all those kind of benefits. But the attackers don't have a 2-week release cycle, right? People that are attacking your service aren't sitting around waiting for change management to agree that their attack works against you. That's not a thing that a conversation that's ever happened anywhere, right? So if you can't move as fast as they do, right, in any capacity whatsoever, if you don't have the ability to get your code out the door quickly in a way that you have control over it, right? It's not some crazy hot fix, okay, Heartbleed came out and we got to light our hair on fire and try to fix it as quick as we can kind of thing. It's not that. It's like, no, this is the way that we do things every day. And we've got this build pipeline and we know exactly how to get code out the door within minutes if we need to. It's not really nice to have anymore. You have to move as quickly as the attackers can. So this stuff's going to get more important as we go. And here's kind of the data to support that, right? So this is a screenshot from the Verizon DBIR. I know it had some problems this year with some other stuff, but I really like this content here, and I think it stands true. But this is basically how to read this graph. Is the top one is time to compromise, and then the bottom one is time from compromise to actual data exfiltration. So as you can see, I mean, the attackers are, the time to compromise from the time they start trying to compromise you to when they actually do is almost always in successful data breaches on the order of minutes. And then by the time they've gotten in to the time that they got data out is on the order of days, but also sometimes on the order of minutes. That's not statistically a relevant spike there. So yeah, good luck with that 2-week release cycle, right? If they're getting data out within days and you haven't even figured out that they got in yet, good luck. And talking about if they figured out if they got in yet, let's talk a little bit about monitoring. So if this is again from the DBIR, and this is a graph about breach discovery method. right? So the top method of breach discovery is law enforcement, which means you got a call from the FBI that said your customer data is on some black market somewhere, right? Letting you know that you got hacked. You don't want that phone call. Second one is, it's kind of floats between some fraud detection service that they might pay or a third party. And I call the third party one the Brian Krebs phone call, right? Someone gets a phone call from Brian Krebs, says, hey, your customer's passwords are somewhere. Or Troy Hunt, oh gosh, there's a new data breach and all of your users are in this database, right? And then dead last there for pretty much every year that they've done this is internal, meaning we discovered it ourselves, which should be obviously the highest priority, right? So I like to say that, and Kubernetes makes this really easy, never let a log die, right? So never let any of your container logs die, syscall logs die, network call logs die, and you got to watch this stuff. Because, yeah, you don't want to call from the FBI. So this is what I call the money slide. And Ryan, I can't see Ryan in here. Is he in here? Okay, I was going to point him out and make him feel uncomfortable. So Ryan Huber, like I said, the talk tomorrow is basically this slide in hour-long talk form. So if you guys are really interested in this stuff, definitely go see it. But basically stuff that me and him were working on, mostly him, we're working on was this kind of roll your own monitoring solution that plays really nicely in modern infrastructure stacks, right? So if your organization can't afford the crazy Splunk bill, this is a good alternative, right? That's like everyone who's ever tried to talk to Splunk always laughs about the price. But so yeah, Elasticsearch is a great alternative. The problem is it's free like a puppy, not free like beer, and you have to really maintain this stuff. So don't go into that job lightly. It is definitely a big undertaking to manage your own Elasticsearch cluster. A cool tool that sits on top of Elasticsearch that's open sourced by Yelp. It's called ElastAlert. And you could do all sorts of threshold monitoring and say, okay, if we saw this many things within this time frame, send me an email or a Slack notification or whatever it is, right? So that ties into Slack bots. Slack is a pretty great security tool if you get creative in terms of integrating with all sorts of alerting mechanisms and let your entire team know or let the very specific people that you need to know as quickly as possible. You could do, and I'm stealing some of Ryan's thunder, but you can do, he works for Slack and he does some really interesting stuff there. I'll only tell you about one is you could ask a developer through Slack to confirm that they ran a certain command on a production box and then force them to use Duo or something on their phone to push a Duo notification to their phone and say, yeah, no, that was actually me who ran that command on that box, even though it was a sensitive command on a sensitive box, right? That's really, really innovative stuff that normally you would pay pretty high dollar if it even exists. And you can build it yourself, not that hard, and there's a lot of open source tools to help you. Our syslog and relp, this is kind of so one of the things that we did early on was build, I mentioned pods earlier, right? Groups of containers. So there's this concept of sidecar containers, right? That can live next to all of your other containers and perform some service for you. So something like an rsyslog sidecar container that can suck all the logs off of your containers and off of the host VMs and pass them along to something like Elasticsearch becomes really valuable, right? This is really, really valuable critical plumbing that you can set up and then build all the alerting on top of that, right? So the project that Ryan's gonna be talking about is this Go audit. It's a Golang rewrite using a tool called auditd that monitors Linux kernels. Really, really, really cool stuff, especially when it comes to monitoring on public cloud technologies. The benefit of the Golang structure is you're talking straight to the kernel. So even really low-level malware, you're going to catch. You're going to see every command run in that box, and you can do all sorts of the alerting stuff with that. How many people have heard of OS Query? Really interested, if a handful of you. Okay, cool. So OS Query is an open source tool put out by Facebook. Does a similar bit to auditd. I kind of like auditd for infrastructure monitoring, and then OS Query makes sense to me for endpoint monitoring, even though they kind of pitch it as an everything monitoring tool. And it's very good at everything. That's just my personal stance on it. But yeah, that's put out by some of the guys at Facebook, and what that does is expose operating system level information in like a SQL query-like format, so you can pull this stuff out really easy. Obvious logs to not let die are Nginx and Docker, right? Like, I don't think I have to tell an AppSec crowd to monitor their Nginx logs if they're using Nginx, but just web logs in general, you're going to want to watch that. You could do some really cool behavior stuff. This is kind of what I have on the bottom here is, okay, there's some anomaly detection going on. You can look for spikes in brute force attempts. One of the things that if you guys have seen Zane Lackey, any of Zane Lackey's talks, one of the things he's been talking about for years is just logging successful logins on your app versus failed logins on your app is one of the easiest things to do, and one of the easiest spotting, easiest ways to spot like a brute force attack coming against your website, right? Is, hey, we saw 10x more failed logins in this time frame than we're used to, right? That's obviously something going on. Super easy to do, but a lot of tools aren't going to do it for you because they don't really know what your login is, right? What does any given application's login flow look like? What does their actual session token look like? That stuff isn't really guessable. It's hard to productize, right? So that's something that you have to do yourself for your application. SSH connections is a pretty obvious one you can alert on with AuditD. Again, the kubectl stuff just laughs at that though. So you have to do some more creative things there. But yeah, the suspicious commands, I touched on that a little bit, right? If you know that what your infrastructure, what your like DevOps guys or ops guys in general are going to be running on any given box at any time to make the thing run, if they go stray from that too far, maybe let's create some alerts and shame them publicly in a Slack room about running curl from a prod box or wget or something like that. This just never should happen, right? Hey, someone hopped on the database and ran curl. Well, why? Let's go put them on stage and ask them why. Yeah, right. It's just never going to be legit. So file watches, you know what files are sensitive on your machines, right? Not any tool that you're going to buy is going to know every file that's sensitive. There's some obvious ones, but there's going to be some custom ones, right? And then, yeah, the anomalies. You can do really creative things like you could do the math on logins of, hey, we saw a login attempt or a successful login or whatever it is from this user, from this IP, and then you could do the math from the next time they log in if it was physically capable for them to travel that quickly. And that'll give you some surprising amount of alerts how many times that kind of thing happens, right? It's like, okay, if they travel in an airplane, good, but if they don't have a TARDIS, they couldn't have done this, right? Like that kind of thing. So you'd be really surprised at how many alerts that generates. So like I said, this is my money slide. I like to leave this up. If you, the slide deck will be on the website, but if you want to see this, like an hour of just this stuff, definitely go see Ryan's talk tomorrow. All right, so I ran pretty quickly. I gave this talk standing in between people and beer last time, so I cut out a few slides. So you never want to be that guy. So I think we have plenty of time for questions if anyone has any. No? I scared everyone? Come on, this was my less scary talk. All right, thanks guys. I appreciate it.